Okay. Before I get into anything, does anyone have any questions about anything in the chapter? Like any thoughts?
Yeah, Jasper. What's an if-let statement?
Unfortunately, that's not in this chapter, but we can go over it afterwards if you'd like.
I'm sorry. Ignore me. Just ignore me.
Anything related to this chapter? Cool. Okay. Then let's get into it. So I'm planning on making this a whole lot more questions oriented. So we'll need some crowd participation. I mean, I already have the questions, but if you have questions, you can ask them too.
Okay.
But yeah, just getting into it. Gonna stop the language server. Spooky.
No.
And then here, we'll see. So if I do this, let x equals 5 and x equals 10.
Error.
So, exactly. So, but there's some more questions here. So, one, does it compile? You said no, but why doesn't it? And how can we fix it?
It doesn't compile because the x variable isn't mutable. And you can add a mute statement after the let to fix it.
Okay. And then what will it print in that case?
It should print 10.
Yep, here. We're getting cannot assign twice to mutable variable x. So it's immutable, so we can't assign to it twice. So there's a lot of different things we can do here. Can anyone think of any other ways we would go about this besides adding the mute keyword?
Is the goal just to make the function print out 10?
Yeah, like how do we make it do the same thing? What other ways do we have?
You could do a print line of a literal 10.
That's true. Sorry, Remy, what'd you say?
Shadowing, guess.
Yeah, that's another way we could do it. We could also shadow and redeclare this variable. And then this would run. Any other ways? Maybe from someone we
I know
haven't
about
heard from.
this shadowing. Yeah.
Sorry, what'd you say?
Shadowing, which has already been mentioned.
Yeah. Okay. So one other way, which feels we could just assign right here instead. Just assign 10 directly because we're kind of not doing anything. Yeah, I think that's pretty much anything. I think that's all of the good ways of going about it. There's probably other ways, but they're pretty much variations at this point. Okay. So what if we did something different here?
We printed out 20.
So if we move it to a different line, does this compile? Yes or no? If so, what does it print? If not, why doesn't it compile and how do we fix it?
I think it compiles.
And what does it print?
And it would print 10.
Any other thoughts?
No, sounds good, I think.
Yeah, because you should be able to do an initialization after you declare it, even if you do it on separate lines. But you wouldn't be able to change it after that initialization line.
Yeah, exactly. We can only assign to an immutable let once.
Mm-hmm.
So that is correct. What if we do something different here? So if I bring control flow in here from the last chapter, or the last chapter of this chapter, does this compile?
No.
Yes. Wait, let me think.
We have differing opinions here.
It looks like it would, because you don't have to, as long as that if statement is formed correctly. I'm pretty sure that's like there's not any other like brackets or anything you need for that. It should compile.
Okay.
Yeah, because you're only initializing it once in the x equals 10 statement. And it's not even necessary. Like you could have a let x, and then like even if you change that if to false, it would still compile. Probably it might give you a warning, but I think it would still compile.
And then Weiss, what do you think? Why doesn't it compile?
I think with the squiggly brackets there, we are in different. So that latex is in a different scope with the one inside the if. Yeah, so like it won't recognize the declared variable x.
I think, yeah, it is a different scope, but I think the x inside the if would inherit from the outside scope, so I think it'd still be able to use it. But you may be right.
Nobody's exactly right. It does not compile, but for a different reason than said. So this is a conditional, and there's nothing for the case where this is not true. So it's possibly uninitialized. So
Oh, that's a compile error. I thought that would have been a warning.
nope, it's a compiler error. That's like
That's
saying,
interesting.
but if we did it differently here, I believe this should compile because it's in a different scope.
Mm-hmm.
So this works and it's 10. So even though it's in a different scope, we're allowed to initialize in a different scope.
That's interesting.
For the other one, we must assign to this variable. So if I do this, x equals 11, let's say. If I go for that, does this compile?
Yeah, that would compile.
And what is x here?
Be 10. Yeah, 10.
Any other
hits
thoughts?
the first true.
Okay. Yep, it's 10, and it works.
That's interesting. So if you just remove that if statement entirely and just have let x, it would fail to compile. Or what if you do a let x and then don't have a print line?
Oh, so if I remove this else here, like this, and then I remove this print.
And then remove the print line, do you still get a compile error?
What do you think?
I think no. I don't think it should give you a compile error unless you're actually using the variable, but I didn't read the message before, so I'm not sure.
Anybody else have a different opinion, or everybody agree?
I don't know how the Rust compiler exactly looks for it because they're much stricter than the other languages, so I don't know.
Yeah, that's true. It might just flag it anyway. Let's find out.
So, you are correct. It's fine. It just gives a warning because it's not being used. But once we start printing it again, we're using that value, and we're not allowed to do that because the else arm is missing.
Yep. Okay.
And the reason for that is pretty much this condition is clearly always true, but otherwise it needs to be evaluated. So if we have like if x is greater than, or like another variable, if y is greater than 12, it has to evaluate that. So it could potentially be false. So we need to make sure we're catching every single one of these. I believe that would be the case. Let's find out. It might be smart enough. I don't think it is.
I
though.
bet that's a similar reason why your match statements have to have a statement for every possible outcome, right? So you can always return something, or it's probably parsed differently, but
Yeah, you're not required to be exhaustive for an if statement, but there is a branch of this code, or that last code, where it isn't true. Like here, we could change y to be something different, and there's a branch of the code where x is uninitialized, so this would not work. So, yeah, what do we think about this one? Will this one compile?
no.
Anyone else have an opinion?
I think no too, because we are not covering all the possibilities of the if.
Yeah. Because it's not going to evaluate that if, so it doesn't matter what condition you have in the if, as long as there's or a possible branch of the if that doesn't initialize the variable that we're using, which is x, it's going to give a compiler error.
Okay. I am unsure about this one, but I think that you're right. Yep, we're getting the same thing here. The binding is uninitialized, and it's possibly, if this if is false, then it's not initialized. So perfect. So let's go back to that simpler example. And let's go through a different example. So what if we did this? Will this compile? If we set x to a string slice.
Oh, wow. That's
Mm.
interesting.
No.
No.
It might. So because you're not declaring a type for that variable in the let x, we don't know what type it is yet. And then in both of those branches, it only uses one type. In the first one, it's an integer, and the second one, it's a string. And so there's not going to be any overlap of the type assignment there. So it might compile.
No, but there, the compiler is statically typed. There is no dynamic typing. So I don't think it should compile.
Oh, you're right. Yeah. So you're saying it's going to assign a type to the variable at compile time, so it can't go between either of them. Yeah, I think you're right. I think you're right on that one.
Weiss, do you have anything to add? I heard you say something as well.
I agree with whatever has been said, like there's a type mismatch, and the compiler will assign the type at compile time, not at runtime, so it won't work.
Yeah, okay. Yep, that is one of the things that Rust does, or Rust requires knowing all of the variables types at compile time. So if it was ever ambiguous, then it will not compile. So in this case, it could be one or the other. They both can be printed, but since there's a different type, I don't think it should compile. Because we could be doing something different that doesn't work for both. Like we could add 5 plus 5, and we can't do that with a high string slice.
Right.
So, yep, we expected an integer here, but instead we got a string slice. So it did not work.
Oh, that's interesting. So it assumes like the first, I guess when the compiler is going through, it finds the first instance of the x being assigned. It's like, okay, that's the type it should be. And then if you try to use something else later on, it's like, hey, that doesn't work with my current idea of what the type should be.
Exactly. It's a stack, so it's going to go top to bottom here.
Mm-hmm.
Yep. Okay.
Cool.
So now we've gone over, or any questions so far? Anyone have anything you want to explore? Okay. So then I have a question for everyone else then. So why did Rust decide to make variables immutable by default? How does this help us as programmers?
Making it, you mean immutable or mutable?
Immutable.
I think it's less ambiguous. It's very clear what can be changed and what cannot be changed. Because you have to deliberately make it mutable. So you are making a more purposeful decision on that rather than just available to change anytime you feel like it. So it's more clear, I guess.
Yeah, I think so as well. I think that's well put. Typically, like it would compile if I decided to set this to 10 as well, and then set this to mutable. Even though we're not assigning twice, it's totally fine with it. It will give us, well, not totally, it'll give us a warning and tell us to remove it. But the majority of the time, developers are going to be using a linter, so exactly what you said. We know the intent of the developer. We know that it won't be mutated. And any references we have to it also won't be mutated. Yeah. Anyone else have anything else to add to that?
I would just say as like a sort of benefit that comes out of that is when you have fewer mutable variables, you'll probably in the long run into fewer runtime errors that you can get when you have like whatever default arrays and other data types that allow you to just change them at will, like even by accident by developers later down the line.
I'll say that's a definitely instead of a probably.
Yeah.
Especially like the typical case of, I'll just use JavaScript since it's a language that does this, but you take an array, you send it over to a different function, and then that can do whatever you want. And if you assume that it wasn't changed, then you could have an issue. Like you index into the 11th item and they just popped off all of the items. Now it's empty. And then you try to do something with undefined. Good luck. But you can set up your TypeScript to get around that, but still, it's a little bit tough there.
Lots
and
of
easy
foot
to make
guns.
assumption. Sorry, what did you say?
Oh, sorry, lots of foot guns.
Yeah, exactly.
I guess at the core, the immutability is about, like you said, conserving data. So, for example, if you, like you said, try to reassign something and you're expecting, well, let's say a string and you get an integer, those take up different bytes within your data structure, and so the compiler lets us know, expecting string data type, like you showed in the example. And so if you're checking, like another example that you just said, specific index, and that index is empty, you could think that maybe I'm just not getting the data, when in fact, the index itself was expecting an integer, but was no longer there. It was a string character which didn't reach that far for allocation of space.
I didn't really understand that, to be honest. Are you just talking about like iterating over a string and having it? Yeah, I didn't get that.
Oh yeah, no, yeah, you're exactly right. So, like for example, an array has this many indexes. Let's say 5 indexes. That many indexes take up so many bytes. When you put just specify data type for that array, you put in strings, right? Those strings take up certain amounts of bytes within that index, and so the entire array would follow that pattern, but integers would specify the number of indexes for their bytes, and so it's not entirely the same for each language, and so you just have to look at the language and see how many bytes they specify in the index. That's what I'm getting. At. Sorry.
Okay, I don't know if that's a benefit strictly of like having non-mutable types, because in any language where you have a data structure like an array, even if it's in JavaScript or something, there's going to be a specification for how it's storing all that data and whether it's allocated to the stack or heap or whatever. And like usually there's what is in JavaScript, there's just the basic like number type or whatever, right? And JavaScript has a definition for like how much space it needs in each one of those array spots for a number. And it's a bit more, since it's dynamically typed, it's a bit looser than in something like Rust, where you can actually define, like you're saying, the bits, like, or the number of bytes in, let's say, an integer. You can do an integer with like 8 bytes or 16 bytes or 32 bytes or 30 bits rather. Sorry, not bytes. So yeah, you have more control over it in Rust.
Yeah, I was just
So
saying
to that, I agree.
Yeah, no, really, it's just characteristic of controlling data. That was just what I was getting at, and so if you were to try to change something, like you said, since you can't change it in the first place, reassign anything, you have to worry about that.
Yeah. And having a data type, well, yeah, just an array being a static array is pretty helpful too, but we'll get to that a little bit later. Okay, let's move on to another thing related, but another tougher question, design decision. So if we have shadowing, what's the point of having the mute keyword? Why not just make every variable immutable and then shadow whenever you need to change it?
Well, when you're shadowing, you can't keep using the other variable. Or rather, you can't, like, where it's defined, like, it's the same name, so you can only use the shadowed version of the variable until you get out of the scope that it was defined in or initialized or whatever. I guess that'd be one reason.
Yeah, but why?
Honestly, I don't like shadowing
this?
that much because it's confusing if you do it a lot.
Yeah, but like, why do this over this? Why beyond like personal preference? What benefits does having the mute keyword give us? And then vice versa.
Well, the shadowing lets you change types if you want, I'm pretty sure.
Yeah.
Which you couldn't do if it was just a mutable variable. I mean, there's probably some like lower level reasons, like performance reasons, but personally, I think it makes it more clear as like a reader of the code whenever you specify something as mutable as it's a variable that's going to change, if you just do it with shadowing, like in the first example, it's sort of unclear because, like we said, by default, variables are unmutable. And so you'd sort of expect that, right? Going in, if you're writing code, it's like, okay, a variable was declared with just let and no mute. That means it's not going to change. So if you treated it that way, it would just sort of go against like the paradigm, I guess, of like what features you have. Like you're using a feature of the programming language like for something it's not really intended for if you used it as a what's the word, replacement for mutable.
Yeah, definitely agree. So if you follow Rust paradigm for say code, say majority of your program uses immutable code, and if you have to or you don't know a better way to utilize that, you use mutable code within a section of your program, your software, and if you have a bug, you're more likely to find it within that mutable code. It's just a Rust paradigm.
Yeah. I had one more thing that I was kind of fishing for here, which is like if we do something with let, if we ever shadow, the compiler will never complain about it. It's fine with it as long as we're abiding by the contract lower down. So we're doing things we can do with an I32 in this case, or whatever integer type we end up making it. So that would be fine. And yeah, like Neon was saying, and a few others as well, just being mutable here shows us we will change it in the future. And the other way does not. So one other thing that this helps us do is if we want to change this here, we can change up here, make it mutable, and then instead of shadowing, leave it here. And then once we're done doing all these changes, let's do like x plus equals 11, let's say. We can just say let x equals x. And then at this point, it's now immutable again. It's your choice, but at this point you're signaling I'm done touching this.
I see like the benefit. I don't like the way you do it. I don't like the way it's done. It seems unclear to me. I mean, obviously if you know the syntax and know that's what it's doing, but it's just not like descriptive of what you're doing, if that makes sense.
Yeah, we're just declaring it immutable. So if we do x plus equals 1 again.
It's like if I was ever doing that, I would feel like every time I would just need to put a comment, be like, make x immutable, just to be like clear. Like that's all this is for. Like that's the only reason I'm doing this. Let x equals x, because otherwise it's a weird statement to put in there at all. Is there any other way to do that? If you want to like have like a small mutable section like that?
Yeah. Getting into another section of the chapter. So instead of doing something like this, in our case here, we can either use a function or a block.
Okay. Yeah.
So
that makes more sense.
Oh no. I have no formatter because I am in non-Rust analyzer mode, non-LSP mode. Okay, let's say temp, whatever. Temp is equal to 10, I guess. And then, okay, pretend this is well formatted. And at this point, we're returning from this block. Oh wait, I won't even say. Okay, does this compile? And what does it print?
No.
And why is that?
Temp isn't mutable.
Exactly. And what about now?
Temp is immutable, and then there's an assignment statement after it. Is why it doesn't compile.
That would be more clear to say it's been assigned to multiple times.
Sure.
But yes, I see what you're saying. And what
Well,
about
yeah,
now?
I mean that's implied when there's an assignment after a declaration of the variable. But yes, I see your point. What did you say? What else?
Yeah, what about now? Does this compile? If not, why? What does it print if it does?
Should print 22, right?
Yeah.
Because it's mutable now. So we set temp to 11. Then we add 11 to it, which is 22. And we have the bare like temp variable without a semicolon. So that's an expression that returns. And in this case, it's returning to the x variable up top. And then we print it out.
Okay. 22.
22.
But we get temp is never used or never read, which is fair because we're just returning it. Let's see what it says if I start the server. This is the most beautiful code of all time. Oh, that's why, because we're... Huh. Okay, it's just because we're writing weird code, but it's a little confused, I think.
Yeah, it's because there's no point in having like a mutable thing there. You should just return 22. Is why it's doing that, I guess.
Yeah, so the other way, since I forgot to ask more questions, there's another way we could do it.
Do what?
Get the answer.
22?
Yeah, like how we could do it in a different way. So what if we do this instead? Does this compile if I actually call it? We said 10. Does this compile?
Would you be defining temp type in the calc function?
I mean, it should. It doesn't use the argument though.
I mean, that's true, but
I
does
don't know
that
if
stop it from
that shouldn't stop
compiling?
it from compiling. It would probably just be a warning. That would be my guess.
So you think it will compile?
No, you need to specify the type, variable type,
Do you?
parameter type.
Oh, because it's mutable. Do you have to specify?
No.
Oh,
it's inferred.
in the parameter. Yep. Okay. Yep. I forgot about that.
Okay, so how can I fix that then? How do I change it? What do I change it to?
Just one of the integer types.
Yeah.
Which one do you want?
Do U8.
Signed.
It's not signed though. We have only positives.
You wanted signed? We can do signed. Okay. Now we have a signed 8-bit integer. Now does it compile?
No, return type.
Return type. Yeah.
And what should that be?
Same thing, I guess.
Okay.
Signed.
We want it unsigned?
Oh, I don't know if that'll.
No,
Will it
let's make it signed.
allow that? I think it has to be the same type as the variable. Well, no, that's the thing.
Does it?
It doesn't matter.
Interesting.
It doesn't matter. Oh, it doesn't matter because the type is going to be assigned. It's going to be inferred, right? where you set let mut temp equals 10, it's going to be
Yeah.
inferred based on what you're setting that value to, or the type to, the return type. That's interesting. So it doesn't matter as long as it's an integer, I think.
I
Come on,
think
let's
so
try it.
too.
I want to see.
I think so too. Oh no,
Is
it
it mismatch
doesn't.
type?
Just compile it.
Yeah, mismatch.
What?
Not because of mismatch type. It's because I didn't
Oh,
put
we're
a
missing
semicolon.
You messed up.
Oh no.
You messed up. We didn't mess up. You messed up.
Okay, now what about now? Pretend that never happened.
It should be good.
Okay.
I think it should
I'm
be
guessing
good.
mismatch type. I think I'm wrong, but let's see.
We can check
I
what
think
all the
it's
types are
inferred.
after we go through, but I think it will compile. Yep, it does.
Yeah.
Yeah.
Did.
Can you check the type of temp, or I guess X whenever it's returned, and it should be like the U8, and then we should be able to change the type.
Well,
and then
X
it'll
is
return a different one.
I8 and temp is a U8.
Oh, I meant in main, sorry.
Oh, and here this is a U8 because this returns a U8.
Yeah. So if you change the return type, it should change that.
It's inferred in this case, yeah. We could
Yeah.
change it to something else.
Change it to an I64.
We could say instead this is equal to X to actually use that. What is happening here? Did I accidentally capitalize? I think I accidentally turned on caps lock. Okay, I'm back.
Imagine having a caps lock on your keyboard mapped to anything.
I have it
Other
on
than
the escape
escape.
key. I don't know how it
You're
happens.
not a true Vim user.
My
Okay.
caps lock is bound to escape and control, so I don't want to hear it.
Okay.
Okay, so now we have this. What about now?
Fail. You fail.
And why is that?
Mismatch type. Because it can't infer. Or it can't what's the word? Like coerce it. Because it'll start as an I8 and then it'll have to try to do something to make it a U8.
Exactly. No automatic conversion.
Right.
So,
Exactly. You have to try to do it because there's, well, why can't it be converted?
Well, it just can't be done implicitly.
Why not though?
You'd have to do it. Well, they're different types, and then if you had like an integer with a negative number and then tried to implicitly convert it into an unsigned integer, it wouldn't map to the correct value that it was to start with. You would have to do some weird conversion to like. It's probably it's just a bad idea. Like you don't want to do it. That's why the compiler is saying it's keeping you from doing it.
is it going to wrap like overflow? I don't
Will it
know
overflow?
what the rest.
Well, not in this case, but it could, which is why it can't do it implicitly, right?
Yeah. They're just different types. Like the I8 is going to use the bit for the sign and U8 is not. And then as you said, it doesn't overlap. But you're talking about, does it overlap? Or what is it called? Does it wrap around if it goes over U8?
Overflow.
An integer overflow, yeah. It might
does
let
it?
you coerce to a smaller type. So if we had like if we end like the X parameter type was I8, and then we converted it into like an I16, it might be able to coerce that by default because it has a larger range that's the same, right? So it's a subset. But I don't know if the compiler will allow that.
That's interesting. What
But
do
it
you think?
it could feasibly work.
Anyone else
Or
have
rather,
opinion?
I mean, you could convert it into it, but I think in this case, it would return an error. I guess like expectation.
Okay.
yeah.
I'm feeling
That's
like
just, I'm just guessing.
implicit. I feel like that would be a nice quality of life.
Mm-hmm.
Oh, nope, it doesn't. So instead,
Yeah.
Okay, so you said it would
just relies
return an
on the
error,
compiler.
but it's the
Me?
Yeah.
it's actually different.
It's a different error, but it's still a mismatch type.
Well, there's a difference here. We have try into versus into. And try into means
so you
that
can,
it could
you can
potentially
use a
fail.
different conversion.
That into will not fail ever.
Right, but you still have to do it manually. You still can't do
Yes.
it implicitly.
You have to do it manually, but it
And-
can't fail.
So
Right.
a quick question, because it can't fail, there's no panicking. But the other one, if it succeeds, it would not panic. But if it does, it would, right?
With this
Yeah.
specific code block, yes, it will panic in the case that it did not work. Which is why, I mean, you could handle it differently. Typically in production code, you would not be just throwing an error, crashing your program in the middle. You're going to do something about it.
Mm-hmm.
But yeah, let's get into the overflow thing. So if we do overflow something, let's say instead of this, we have let's say we have a U8 that's 255. And then we make it mutable. And then,
So that's just a literal 255 with a type of U8.
yes, it's a type of
Okay.
250 or type of U8.
Okay.
Yes.
So the underscore doesn't mean anything. It just is saying this is a type.
Yeah, you can put an underscore anywhere in a number. So like, for example, we do
So you could
111,000.
remove that underscore and it would still detect the type. Like
Yeah, it would still work
no underscore
the same.
Okay.
You could also add as many underscores as you want. You shouldn't though, but you can. Okay. But now, what do you think it's going to do? Will it compile? Will it not? What will happen here?
It'll wrap it back to the
Yeah. It'll do an integer
so
overflow.
the 0.
Yeah. It might give you
Any
a
other
warning,
opinions?
but it should compile.
Wait. Since we haven't fixed the other error, wouldn't it just throw that same error again?
This one, we don't need to worry about the calc function because we're not using it. Let's just pretend that's not there. I'll just leave it
It'll
for.
be 0. It'll be 0.
It's in the chapter, but yeah. Okay, let's go for it.
Error? No.
So, wait, you said error?
Not error. What is
No,
it?
you'll get 0. It wraps back, right? So you will get a 0, I think.
Pronounce 0 or would it? Sorry, I'm risk. Sorry, go ahead.
It will print out 0.
Oh, print out 0.
I guess it will result to a compiler.
Okay, so we have lots of options here, I guess. Compile error, runtime error, or it'll work
0.
fine and be 0. Okay, let's find out. So, I don't know if I saved.
Wait, it says 0 right there.
Where? I think it just did something weird, but yes, it does a runtime error.
Oh, wow.
Attempt to add with overflow. So there is, but if we run in release, it does 0. So you're both right. Well, if somebody said compiler error, then they were wrong, but everybody else is right, technically. So
Oh, that
in
is
debug
crazy.
mode, it errors. Otherwise, it just wraps around.
Oh, that is
Which,
awesome.
but to get around that, instead we have some nice methods. I have to wait for my. Okay, yeah, here we have all these methods like checked add, and they will, instead of just rolling over, here we'll check if there's an overflow, and if there is, we'll do something about it. We can choose that, and then same thing with division. We also have saturating add. So instead, it will stick at 255 instead of rolling over. So we have some nice methods. We also have overflowing, add signed, like all this kind of stuff here. So there's nice methods to get around that. But another question, does this compile?
I don't see why it wouldn't. It's just
Same rules.
If I told you that a U8 is from 0 to 255,
oh,
would you change your mind?
I didn't see that. Yeah. Yeah, it probably does throw a compile error in debug mode, and I don't know if release will automatically overflow it or not. Probably.
I mean, can you run it in release mode if it doesn't compile?
I don't. I guess that's true. If it's a compiler error. Huh.
Will the compiler tell us, since it's just printing out X, will it like say anything about like we're defining it as mutable? Or will it just like not care since we're not
I don't think it doesn't matter that it's mutable, I don't think.
We would get a
It's
warning.
just that
Oh, really?
If it does
Sure,
compile, we'd
yeah.
get a warning. But if it doesn't compile, we'll get the error.
Okay.
Mm-hmm.
Okay, so
Does it show both at the same time? Sorry,
I
I'm just
don't know.
I'm just curious.
I mean, we'll find out. Let's
Sorry.
see. No, you're totally
Sorry.
fine. That's what we're here for. We're here to ask questions. We'll find out. What do you think?
I think both. I mean, compilation error would be more important than just a warning, but I don't see why not would I print both. Just in a log.
I feel like it would do one because it wouldn't get to the point where it'd be able to find out if it was ever changed.
Yeah.
But I don't know.
If it fails the compile time, it wouldn't run to get a runtime error, basically.
Well, we're talking about a compile time warning.
Oh, in that case,
Would the compile time warning show up as well, or would it only show a compile time error, assuming this does error?
yeah, I don't know about the priorities for the compiler on that. So maybe not.
Let's find out. So here we get both. We get a warning.
Oh, wow.
And we get literal out of range for U8. 256 is not fit from the range 0 to 255. And if we're doing all this without the language server, but we would just see that right here and get both of them at once. And we get all of the beautiful things like quick fix. There's no quick fix for this though. Convert integer base. Whoa, what is that? Remove digit separators? That's so beautiful. Oh wait, no. That just changes the base.
Nice.
But that's actually pretty nice if I ever need that. Okay.
That's really cool.
We went over almost everything. Oh, well, we didn't go over all the number types, but I don't think we need to.
I don't remember them all.
We have 8-bit, so just to go over it, we have unsigned integers and signed integers. So I8 is going from, I believe, negative 128 to 127. So if we did something below that or above that, it wouldn't work. And then unsigned goes from 0 to 255 for AU8. And don't ask me for any of the other ones. I'm just going to go over them. We have I16, U16, I32, U32, I64, U64, I128, and U128. We also have I size and U size. And does anybody...
Pretty big numbers.
Yeah, really big numbers. The default here, does anyone know the default?
It's probably I32. You mean like if you have a number and then don't say the type?
Yeah.
Probably I32.
64, I think. I64.
Let's find out. I32.
Really?
Yeah, it's I32.
Wow.
That's like every integer is always default's always I32.
Well, yeah.
Like not always, but it's a safe bet because otherwise you have to think about running it on 32 and 64-bit architectures and changing the default of that. When if you just leave it I32 by default, it will work on most places.
The one exception
Architectures.
to the rule here is if we do something that relies on indexing, that is typically a U size. Because it is very much based on the architecture.
Okay.
But yep, if you're ever worried about it, if there's a case where it makes sense to do it, which we will get into, then it definitely makes sense to use a different number type. But if you're just going about doing your thing, go for I32 if you're just using a variable and it's not going over that like billion or something it can go up to.
It's about
And
4
then,
billion.
Yeah. And then usize if you're using any kind of index collection like an array. And you'll see, well, getting into that, will we see? So if I do this, does this compile?
No.
No.
And why is that?
You go
Index
ahead,
out of bound. Yeah. Index out of bound, I guess.
Yeah, exactly. Index out of bounds. Length is 1, but index is 256. So exactly, it will not compile. And then what if I change this to 0? Does this compile?
Yeah.
Yeah, it should.
And then beyond
Yes.
that, what type is X here?
I32. Oh, U size? If it's inferred. Maybe.
Anyone else have any thoughts?
No.
Okay. So yes, it compiles. And also, yes, it is U size.
Oh, that's cool. So it infers it from like the print line where you reference it as a index to Z. That's
Yeah.
cool.
It'll infer it depending. That's why if you pass a number to a function, you don't have to specifically say, okay, this is a U32. It just knows, can this number work as U32? But if I do explicitly here, it's going to say, nah, don't do that.
That's so nice.
Wait, you didn't type out the type.
I did.
It gave it. It's just said 8. You were getting a different error because it was 0_8.
Oh, okay.
Is what you typed.
Well, then here, exactly what we were saying, type integer cannot be indexed by U8. So even here, this is saying this can be any integer type because 1 fits in every integer.
Cool.
Okay. So then, before I forget, let's get into some other types here. So we already kind of did before. But let's get into another thing. So if we have, oh no, I have to turn off the server. We have to ask if it compiles. And let's print something. Let's print hi. Does this compile? And if so, what does it print?
I think that I'll let somebody else answer.
It won't compile.
Won't compile. It's not a Boolean. X is not Boolean.
Yep, exactly. So if you're coming from a language like JavaScript or Ruby where they're very lax about what you can put in here, any condition here in an if statement, well, in Rust, if expression, this must be a Boolean. And if not, it will not work. So ultimately, I don't think there's much to talk about there. Just you have to be explicit about what is a Boolean and what is not a Boolean. I won't try to coerce it. And then another type is char. So character is equal to H. So we define characters with a quote, or sorry, single quotes instead of double quotes here. So question here, does this compile?
Going once, going twice.
I don't know. Is this does that have a Unicode value?
It won't compile. Because yeah, it's supposed to be a single Unicode character in single quotes.
Exactly. And it's even going to let us know what to do. There's more than one code point in this character literal. And going on to something different, we'll pick Halloween. Does this compile?
Yes.
What do you mean? This is obviously the Thanksgiving Rust stream. That should be a turkey, my friend.
Too late.
No. Okay. I think that's fine. It's
Yeah.
Unicode.
Here's your turkey. Turkey Ferris. That stream does not get to see, but it's in chat. But yeah, let's see. It does indeed work. But while we're at it, a more fun one maybe I'll pick Turkey now. Turkey. Does this compile?
There's no way that the Rust specification allows you to use emojis as variable names. There's no way. And if you tell me the opposite, I'm going to quit this Rust stream.
Of course.
Right now.
It's best practice
It's
to
pretty
use
hilarious
emojis.
if it could. I don't think you can.
You can't. There's no way.
Identifiers cannot contain emoji.
Good.
Jesus, great. They already know.
What if we do this? Does it work now?
Oh, maybe. That's maybe.
You're hilarious.
No. It says use Ferris instead.
That's awesome. It has a message to use Ferris. Hell
That's
yeah.
fantastic.
That's great.
Yeah. So ultimately,
Copyrighted.
a
Rust has
char.
the best compiler.
Yeah, so good. Ultimately, a char is just 4 bytes, so it'll fit emojis in there, and then any of your. But just keep in mind that what you think is a char and what Rust thinks is a char may be very different. I think we already went over integers, but going over something a little bit more interesting. I don't think we went over it yet, but let's just print it, actually. How am I supposed to type without without my autocomplete? This is so terrible. Okay, so what if we do this? What does it compile and what will be printed?
Two, 3.2.
Yep, exactly. It'll print 2 because it will just be an integer. There's no fractional part to this, but what if I do this? Does this compile?
It should.
Nope. Doesn't compile.
Nope.
Because we can't do float by
dang.
integer.
Yep, it doesn't
Oh, wow.
coerce the type. It can't do it.
And what about this? Does this work?
It should work
Surely.
now.
And what will it say in the console?
2.5.
Yeah.
I hear the fear. Yes, it will. It is 2.5. Yeah, it is. The default.
Fear the float arithmetic.
Yeah. So it's kind of, if you're unfamiliar with floats and integers in general, I recommend the Rust book does say do like a Fahrenheit to Celsius calculator. I think that's a pretty good exercise to figure it out or get used to it. But yeah, floats are pretty much the same thing there. Does anyone know the default float type?
Ah, 32 or 64? I don't know.
I don't know. Probably float 32 or float 64.
It's float 64.
Yeah, one of 64. Okay, so
okay.
double precision.
Yeah.
Yep, float 64.
Is there a float 32?
Yes.
Interesting.
It has single precision, I think. For
Yeah.
32.
I always forget like how precise those are. Like how many decimal points can I get to before it's just useless or incapable of more precision.
More questions, Spooky. Does this compile?
Yes.
Yes.
Negative 2.5.
Yep, it works. Floats are also signed. They're all signed. There's no unsigned floats.
Yeah.
Okay, I think that's all of our more basic scalar types here. So let's move on to some more compound types. So, of course, time to ask if things compile again. I'm just going to remove this function here. So if I do this,
It won't compile
and why not?
because elements of array has to be the same type.
Yeah, exactly. What if I do this? Will that compile?
No.
Why not?
Oh. Oh, yeah.
It will compile.
And what will it print to the
Will it?
console if it does?
Hi.
I don't think it'll compile.
And why not?
Because I don't think semicolons can be used. I don't think that's a valid like data structure syntax. For an array, I think the semicolon isn't allowed to be used like that.
Okay.
Isn't it tuple represented like that?
I think tuples use parentheses.
Oh, yeah.
I might be wrong, but I don't think you can use the semicolon like that. Uh-oh.
I'm just debug printing the data structure so we can look at it.
Okay. Yeah, but you wouldn't be doing that if it was a compile error like I was thinking.
Oh, well, there is no compile error. This is perfectly valid syntax. This is shorthand for
Yeah,
an array
see?
of 5 highs.
Oh, yeah.
I read that and I forgot.
Oh my gosh.
Yeah.
Yeah.
I literally read that like, okay, well, I guess it was like over an hour ago now, but right before the stream started.
Ooh. And then what's the type
Yeah.
of A here?
String.
It's like an array string, like
So
array
you're
with
saying it's
subtypes
string.
of strings.
Like that?
No, there has to be like an array type on top of that. There's no way that it's just string, because that's going to be what each element is, and it's not like a union in C or anything. I don't think.
I'll give you a hint. It's similar to this. Similar to the shorthand.
Really, you can do. I would say it's like.
Oh, you have to have a string, string semicolon 5.
No way. There's no way.
Exactly.
Yes. Elements,
Huh.
yeah.
Yep.
But you have to specify the capacity.
Yeah, arrays are you cannot change the length of an array.
Mm-hmm.
They are static arrays. If you need something dynamic, anybody know?
but it can't like infer the length of it. I mean, like
Oh,
if
it
you just
can.
had like an array with string and then didn't have the 5 in there.
It knows.
No,
That's
but
why it works.
can you specify that it's a array of strings without the 5, like the capacity of 5 in there, and have it infer just the 5? I know that would be weird, but
Like that?
I guess if that is syntax that you can do.
I'm unsure if you can.
Yeah.
Oh, I forgot the. No, I forgot a important piece here. I think it is
Okay.
possible.
Yeah.
Well,
I
it
was
says
just curious.
consider specifying for 5 using.
array
Okay,
element.
so it's unstable. So in the future, potentially we can, but for now,
Neat.
no.
Okay. Cool.
But it can be inferred like this.
Yeah, you can just leave it blank and yeah. Okay. Cool.
Does this compile? It's spooky.
We don't.
I think yes.
No. We are not accessing the. This is a tuple now, right? It's not an array, but we do not access the. It's like the elements like that. It should be a dot 0. Yeah.
So you're saying
okay.
like this?
Yeah.
Okay.
Oh no. Yeah, I think. Do we need to specify the type for when you declare tuple?
It can be inferred.
Okay.
So yeah, exactly. You're exactly right here. It is 0, 0, or not 0, 0, 0.0 to access a tuple type, and we are allowed to have different types in here. And if I start the language server here, it does infer this. You could specify if you prefer, but you don't have to. And if we run this, it says, hi, and here's our tuple.
I love tuples.
So yeah, they're amazing. Another spooky one, and this one is directly stolen from the Brown University Rust book, but we're going to do it just to get, because it's very good to show everything we can do. Ooh, good review. I'm picking random numbers, so it's a little bit different. I have no language server. What am I supposed to do here? I tried to rename all and I couldn't do it. Okay, so does this compile? If so, was it print? If not, why doesn't it compile? And how do we fix it?
A 0, that will be 1. And G dot 1. That will also be 1. No. 5.
I think you're almost there. Yeah, I think I
1
get
and 5.
where you're going. Yeah, it should add.
One
It should A0 should get
is
us
1.
the first. Yeah, it should get us the first one in that first array, and then T.1 will get us the second array, and then the bracket 0 should get us the first 5 in that array. So we have 1
Yeah.
plus 5,
Plus 5. Yes.
which would be 6.
Yep.
Yeah, I think that checks out.
You sure about that?
I'm
No.
positive.
Ooh.
100%.
What if there's ownership issues here?
No. We haven't gone over that.
Resigning.
It can't be.
Yes, we don't know anything about ownership.
What if it's a precursor to the next
You're-
chapter, which is ownership?
Nah.
They're assigning both A and B to T, and so you're calling both when you print. So, like you say, ownership. Okay.
I don't think ownership is an issue here because we haven't done anything that requires us to think about it.
What if this is the first thing?
No, there's nothing in there because it's literally just assignment statement of a tuple with 2 arrays and then a destructuring of that variable and then printing them.
Yeah.
So, yeah. Eat that.
Yeah, you're right. There's no things here,
Oh, wow.
but we could potentially. These arrays are copyable, but if they weren't copyable, we wouldn't be able to do it. Then we'd have an ownership issue.
Oh, okay. Okay. I'll be ready for the next chapter. Don't you worry.
Like,
I'm gonna
for
read
example,
I'm gonna read that chapter twice.
skipping to
We're
something
like,
like a vector. It doesn't work.
Uh,
Oh, well, actually, it's because their type's wrong, but let's try it again. Oh, no, that works. Scam.
yeah, I still don't know how.
Are we using
the
B again?
ownership
I have no
system
clue.
works.
Oh, well.
Oh, because B isn't used. It's not referenced.
I thought I tried it before and there was some issue with it.
With the vector?
Was it an array of vectors or something ridiculous? I don't think
A
these are
vector of
copyable.
tuples.
Oh, yeah, okay, so here we go. If we
A vector
decide
of
to make
vectors.
an array of vectors, then it's not okay with it. But so there's a...
Well,
Oh, we can't add.
oh.
Oh, never mind. Wait. Oh, no, there's both here. 0 of 0. Perfect. Yeah, we can't... Oh, no. Well, ignoring this piece, yeah, it's not satisfied here. So there's potential situations where that wouldn't be okay, but our values were all fine. And as seen by that beautiful display, ownership is fun. It's one of the toughest concepts
Indeed.
in Rust, but it lends itself very well to doing lots of questions like these.
Yeah, that's a foreshadowing for next week when we'll be here for 4 hours.
Ooh. I'll try not to. I think this is...
No.
Maybe.
I'm sure we won't, but...
Are we meeting
it's so
next week?
spooky. Oh, that's a good point. Next week is Thanksgiving, isn't it?
Then let's not.
Or Wednesday, the day before. I might
yeah,
not.
if you guys are
I
traveling.
might not be here. I'm not sure.
Yeah,
With my
let's hold
plans,
off
yeah.
then. I didn't think about it.
So
Week after next. Cool.
See, now I'll have 1 week to read chapter 4 for the first time, not do it, and then a second week to read it for the first time.
And you could read it during the book club.
Right.
I don't think I can.
That's
do
always
that.
my backup plan.
I
Always
definitely
my
need time
backup
to
plan,
digest
which
this.
becomes my main plan, plan A. It always gets upgraded.
Jasper, you're one of those teachers that assigns 2 chapters over break.
I don't. For ownership, we're not assigning 2 chapters. There's no way.
No.
That's like this
Thank
chapter
God.
was like a little bit much because there's a bit in here, but that's even like these are simple enough to understand. But ownership is like, yeah, interesting.
Oh, thank goodness. Thank
Yeah. Okay, let's get into. I'll talk about it a little bit later. I just want to finish up real quick because we just have to get through like the looping data structures, or not data structure, control flow. But yeah, let's get into it.
Let's go.
So
Oh no.
so instead of
Don't
quizzing,
do
I'll
it.
just go into it. If we do this,
No.
we will loop forever
Abandoned ship.
with high. So,
Abort.
but so loop is good. It's like a while loop with while true, except for we have one extra thing. We could also. Sorry, what'd you say?
I just mumbling to myself. I do that sometimes while reading. No exit condition.
Yeah, we could do some kind of exit condition, like a break. And if we do break, then it will return that value. So we could do 4. So let val equals 4. And here we can print that val. So if we run this again, instead it's saying I'm not using the value because I did it wrong.
Your print line is missing.
And Rust is telling me this is a useless loop. Why did you do that? And I agree, but it's for an example. So we have high and 4. And something happened to my terminal and I don't know. But
Wait, hold on. Is print a separate macro from print line? Does it just not do a new line or something?
Oh yeah, it doesn't. You're totally right. Yeah, there's no new line if you do print. Yep, that was it. Yep, so we can do it and then, but we will be informed that I'm not looping. So there's not really a point in doing this, but I'm aware. But you could do like a condition, like if you hit 4, you can loop and break and do something else. But as well, so if you need to loop indefinitely, that's a good one to go for. There's also while loops, which go over a different condition, and while let loops, just like if let, that we might go over at the end. Ooh, spooky. We have while, so we could say while true, go over the whole thing. We could say while I is less than
I 128. Hold
0.
on. Timeout. Go back. I goes up to 128 bits.
Yeah. Pretty good, right?
Is there an I256?
No.
Oh.
At that point, you just use strings.
More numbers.
There's
than
not really a point.
Atoms in the universe. So. Yeah.
Let's say this is equal to 10, and then we can loop down here. So I minus equals 1. And we can print in here. And this will do what you expect here. It'll loop 10 times. Well, actually it won't, because I said it is less than 0. It'll loop 0 times. Doing it again, it'll loop 10 times. Perfect. But the issue here is it's easy to make mistakes. Like we haven't, this is signed, so it works. But if it was unsigned, we might have issues going under, out of bounds potentially. And then it's just easy to infinite loop with a while loop without meaning it. So typically, iterators or for loops are preferred. For loops actually use iterators under the hood. But an easier way to do that same thing, count down from 10, would be doing, let's say, for I, and then we can do a range. So we do 1 to 10, and then we can reverse it. I forgot in here. And then here, this will work. And we can loop through. So this does the same thing, except for we don't really have an option to break our code. It won't ever error during runtime, so we're fine. And then if you want to go the regular way, you can just get rid of your reverse and do a regular range. And now you're going up. As well, you can loop over an array or some other collection. You can loop over hash maps, like a lot of things. Anything that implements into iter, you'll be able to do. So we can say let array equals 1, 2, 3, 4, 5. And then we can just do let I and R. And we can loop over them, everything we put in there. Any questions about our loops? Okay. To give us a little, oh, sorry, go ahead.
I was just gonna say, are there any more looping structures? You mentioned a while. I guess we'll go over while let if we get to it, but there are other variants, I guess. Still,
Yeah, there's other variants like while let is pretty much while that value is okay, it's going to take that value. But yeah, you can get to it. You could do, I don't think it makes sense here at all. But equivalently, while let some, let's say I, can we do that? I don't know.
we can get into that.
We'll get
later
to
once
it.
we've done
Oh, okay. Okay, it's
the error
equals.
handling stuff.
It's not in, it's equals. So yeah, it's telling me, hey, why did you do that? This is not a good use case for this, but it does the same thing. We're saying while there's more values left. Oh no, we're not. We're making an infinite loop. Because I'm making the iterator every time.
Call the next.
Yeah, because I recreate the iterator every time. And now it is immutable, so we can't mutate it. And then yeah, it's actually telling me that. But yeah, they're like, why don't you just use a for loop here? I've used it before, but I don't know where I used it because it doesn't really make sense to do. But yeah, beyond that, it has the other ways to loop, which are just like you can do a for each. So we could say 1 to 10 dot for each. Typically, you want to do a regular for loop if you're doing this, but you can. So we could do just
if
print
you want to
this.
do it like functionally, where you chain a bunch of stuff together.
Yeah.
You might want to do a for each. Okay.
But it does just like anything, like in JavaScript, it doesn't return anything as far as I know. I think it returns unit. Yeah, it returns unit. So it's not super helpful beyond that. If you like it better, you can do it. You can chain it. But the better use cases of looping like this is you have lots of things here that help you out, like sum. You can just get the sum of everything without having to write your own reduce or anything like that. You also have things like product. We can get 1 to 10 as a product. So I guess we can do that. Okay, yeah, this is not a thing you can do. You have to throw it in the end.
Yeah.
Okay, this is fine. We just need to tell it what number type we want the product to be, and then we're set. And yeah, we get whatever that is. I can't verify that for you. Let's just do 1 to 5 because that'll be 15 if we sum it. Yeah, it's 15. So it's fine. So you get a bunch of nice methods like that. And then unlike in JavaScript, they don't create a new data structure for you every time. They just go through it. So like a map won't do anything until you use it, because there's not really a point to using those values. And because of that, there's nice like parallelization libraries. But yeah, let's get into the next chapter before I talk about iterators too much. It's one of my favorite parts of Rust, though.
Iterators are neat.
Very nice.
And powerful.
So, ownership. Very fun. We'll get into it next time a bit more. We don't have that much time to talk about it, but here only one value can, or one binding can own one variable. So you'll have issues when you start getting into more complicated things. So like if I say let string equals a string, and we have hi. If I decide to give this to another value, so numbers, they implement copy, so they're allowed to be copied. But in this case, if I say string 2 is equal to string, this is fine. I'm allowed to do this, but once I get deeper here, if I try to use string, it's going to say I can't use the value anymore.
Yeah.
So that's a good thing for our code, because we can't have two things that point to the same thing, or that are the owner of that value. And it helps out with a lot of different checks as well. I'm not going to get too far into it, but yeah, everything has one owner. And then once this goes out of scope, you can't use it anymore. So if I decided to scope it differently, then it would be like another issue you might run into. Probably not. This is a contrived example. But if I decide to assign string here, that works. But if I don't own this string, I'm just using a string slice. Okay, that's also fine. Oh well.
I think Rust is weird about
Oh no, it's fine with it.
coercing like slices sometimes, isn't it? Doesn't it?
Oh,
It
I have
treats
to bind
strings
it in
kind
here,
of
I think.
differently.
I think I have to bind it in here, and then it's not okay with it.
String 2.
String 2.
Better than string 1.
So if I do that, it's going to say, okay, this value isn't living long enough, so I got into lifetimes on accident instead. But let's just, we'll get into it later. It's a really tough topic. But it's, luckily you can't break it, and there's good reasons for why it's there, but yeah, I'm not going to get into it right now.
Yeah, we should definitely. I'll see. Remind me if I forget, but we should look up some of the reasons, if they don't go into detail in the chapter, about like why it's a good idea. Because I think I need some motivation to learn like the ownership model, honestly, because it is confusing to write around. Like you're fighting with the borrow checker and everything. just to get your code to work sometimes.
I'll get into it in there. Like, I kind of get the reasons why. I'm pretty sure I'll be able to go over it well. But it's hard to know if you haven't been in or like worked with a language that doesn't require you to manage your own memory pretty much.
Yeah. That makes sense.
But yeah, I think at this point we can call book club over. But as always, or as we've done before, I'm glad to answer some more questions. So like, don't feel like obligated to stay. It's just like extra questions for anyone that has them. Yeah. But generally, how did everybody? Oh, sorry. What'd you say?
I was just gonna say I've got to dip soon, but yeah, if you're gonna wrap up, I think all my questions got answered. So
you asked about some, so we'll do it. If I have some value here, like I have 2, I know that there's 2, but potentially we did some operation and we don't necessarily know if this value is okay, or not if it's okay, if it's some, if we have some value here. So if I do if let, and then I can pattern match here, so saying some val here is equal to some, then we're going to print it. Well, I did not print it, but you get it. And then we could also do an else here and say else.
But wouldn't that sum resolve to just like nothing, like the unit type or whatever?
No. This is going to print 2 because it has 2. If I put the unit type in there, it would.
Oh, it's setting it equal. That's weird.
Yeah, so in this case, we get the value out. Sorry, what did you say?
I understand. So it's running that if statement with it's basically setting a new scope with a variable assignment in there, just like embedded in the if statement.
Yeah, exactly. So like,
okay. I was reading that syntax wrong.
We can do that, but otherwise we'd have to do. I might be totally wrong on this, but we'd have to do some longer syntax. So like, if sum dot is sum, and then in here, like you're mentioning, doing it kind of in the header with our destructuring when we're talking about that. So if this is sum, then let val equal to sum dot unwrap.
Yeah.
Oh wait, do I need to do that?
Or
oh well, Clippy's okay. It's fine. Clippy's just saying, why did I do that? Yeah, of course. So it knows that this is fine at this point. And that just protects.
Was the if let implicitly unwrap the sum value?
Essentially.
Okay.
So it checks if it's sum. And then if it is, it does it. Or it binds to the variable that you give it. I don't know if we can look at any of the definitions. I don't think we can look at the definition for pattern matching. But yeah, a shorter way of doing that. Am I able to go to definition? Nope, I don't think so. But yeah, it's just a shorter way of doing something when you don't care about all the outcomes. Like if it is sum, you want to do something. And if it's none, you're just going to ignore it potentially. Or if there's an error, you want to do something with it. Or if there's a value, you want to do something with it. But you don't want to do both.
Okay, so. Cool.
But it looks exactly like a match. So if I do match sum, we have sum, and then we're doing something with this value.
Yeah.
And then if we have none, we're doing something else here. But here we're required to go over everything. So it's just more helpful in that case when you don't care.
Cool.
Yeah. Did anyone
Okay.
else have anything they wanted to go over?
I'm good.
Yeah, I think that was my only other question. So I think I'm good.
Well, if there's nothing else, can we get into some feedback? How does everybody feel about like how long the session was? Because it was like an hour and 40 minutes at this point, I think. And then like, how do you like having questions like that instead of me just kind of reading over the chapter with occasional questions?
Definitely a bit long, but 10 out of 10 on the format. I like it a lot. It's
I
definitely
do
more
as well.
engaging.
I
It's a
like the
question.
format.
Sorry, go ahead.
No, I like this format as well. It makes you think.
Mm-hmm. Yeah, I think this will definitely help make it stick more than just doing mostly a chapter like review. Doing it like more hands-on, back and forth.
Yeah.
A question and answer format, and then having another like digging deeper example.
Yeah,
After
it
that.
gives a lot more opportunities for like little tangents or exploring stuff than strictly just what's in the chapter as well, which I like.
Okay, nice. Yeah, I felt like we needed some more user engagement because otherwise it just ends up being like one or two people talking the whole time. And this way we can get everybody in on it and thinking about it.
Yeah.
And we'll need it for ownership.
Yeah. That might be a 2-week chapter, if I'm being honest.
Yeah, we might do that.
Yeah.
If it's like on the super tough ones. If y'all are feeling like we need another week on it, we can go another week.
I would not be against it. Or maybe even doing ownership, then doing like another chapter and then like going back to ownership even, because the chapter after that is structs. So we could do like ownership, structs, and then you go back and do ownership again, but like apply it to structs or something.
Ownership
I
is
don't know if
just
that'd
kind of a part of all the code, so we'll run into it more. Like if you're gonna
Yeah.
destructure something from a struct, you can't just use that struct again because it takes ownership of everything in the struct.
Yeah.
I think we'll get good practice with it. It's kind of
I will let
unavoidable.
you know.
Yeah.
I will let you know after I read the chapter. I'm completely due to rest. So
Yeah.
Yeah, ownership's the three things people talk about. Are there three? I forget. Ownership. Oh yeah, ownership, borrowing. Oh, we get into ownership and borrowing in here, and then lifetimes. And
Yeah,
ownership and
'cause they're
borrowing
sort
is
of-
unavoidable, but lifetimes you can
Yeah.
avoid somewhat.
Lifetimes, I just
You don't need to get into it unless you want your program to be super efficient, which most of the time you don't need to. And if you do, you can figure it out.
I suppose. But
I mean, there's
I can't wait. I can't
lifetimes
wait till we
here,
get to that chapter.
but specifically generic lifetimes are the tough part because regular lifetimes are just like scoping rules, like this is dropped after its scope kind of thing. That is a lifetime.
The syntax is kind of opaque, unfortunately, so that makes it even worse. Or not opaque, but like weird. It's weird to read, in my opinion.
Generics in general, or
The
lifetimes?
lifetime syntax, like it uses what, like a single quote and then names which you like attach to different things. I don't know. I never really understood where they needed to be applied or why, so that's probably why I'm still confused about them. And like the syntax as well.
I'd like to say I am, but I don't think so. I will question it. I think I kind of get it, but maybe this will be my like aha moment. Up to this
Yeah.
point, I've been able to get things pretty well, but we'll see. It's
I
tough.
looked at the lifetime and generics when I read the previous chapter because he was referencing it, and then I went and looked it up because I was getting confused what was he saying. So I think I'm okay with the generics, kind of.
Generics are amazing in Rust. Very nice.
Yeah.
Very nice.
One day we will get into them, but it's very, very nice.
One day. It's only chapter 10.
Yeah, we'll see.
Rust is like efficient as C++ and much easier than C. Like there is no memory allocation, so half your problem.
No manual memory allocation.
Yes.
You
Yeah.
can,
Oh.
but it's not necessary unless you need optimizations.
Yeah. I have a question. At this menu, in the functions, if you pass like arrays or anything like that, are we passing? Never mind. I answered my question.
By reference.
Yeah, by reference or.
Depends if you specify by reference or not. Which is a great thing about it.